What's up, everybody? This is Danny Mathematics here with another example to explore. Today, guys, I want to go over example 1 of solving inequalities with variables on both sides, right? And if you watch my videos of solving equations, it's literally the same steps. The only difference is an inequality has an inequality sign versus an equation has an equal sign, which there are slight differences to those signs, right, and what they mean. So I will get into that. But 90% or 95% of the steps are literally the same, okay? So remember, guys, all we want to do is we're going to follow these steps to solve for x, because x has to be a certain value in order for this to be true. So what this is saying, guys, it's saying -2 times parentheses x minus 12, parentheses close, minus 5 times parentheses x plus 2, parentheses close, is less than -9x plus 4x, right? So since this is an inequality, it's saying that x can only be a certain range of values that will make this particular inequality true, okay? So once again, guys, this sign right here represents less than. All right, so due to particular values of x, the value of this side will be less than the value of this side. So we're trying to find out what are the range of x values that will make this whole inequality true, okay? So let's go ahead and solve, guys. All right, the first thing, guys, is we want to do step 1. And step 1 says combine like terms on both sides. But if you notice, we have parentheses, so we also need to distribute before we combine like terms. Or in order for us to combine like terms, we have to distribute, okay? Which means that we need to get these values out of the parentheses by multiplying by the coefficients, right? Which are the values that are attached, okay? So let's go ahead and do that, guys. Okay, so I have -2 times x, and I have -2 times -12, right? So -2 times x is -2x. All right, it's -2x. And then -2 times a -12 is a positive. It's a positive 24. Okay, it's a positive 24. All right, now I'm going to the next one. Now it says minus 5 times parentheses x plus 2. So I'm going to do -5 times x. -5 times x is -5x. It's -5x. Okay? And then -5 times positive 2 is a -10. It's a -10 or a -10. So I'm going to subtract 10. I mean, not subtract. I'm going to put -10. My bad. -10. Okay? And then I still have this other side, which I don't have no distributive properties. So everything on this opposite side comes down the same. Okay? So I have -2x plus 24 minus 5x minus 10 is less than, right, -9x plus 4x. Okay? Now, ladies and gentlemen, I can successfully combine like terms, okay? So I'm going to combine all the x's with coefficients with each other, with one another, and I'm going to combine all of the single numbers, right, or the integers rather, right? I'm going to combine them as well, okay? So let's go ahead and start on the left side. We're going to combine like terms. Let's combine -2. Let me make this negative sign be red so y'all know what I mean. Okay, so I'm going to combine -2x with -5x, right? -2x plus -5x is -7x. That is -7x, okay? And then next, guys, I'm going to combine a positive 24 with a -10 means -10, with a -10. So 24 minus 10 is 14, okay? So once I combine those two values, I will get 14, okay? So I'm done with combining like terms on the left side. Let's go ahead and try out on the left side, let's go ahead and try out the right side. So I have -9x and I have a positive 4x, and yes, they can be combined because they're both like terms. Negative 9 plus 4 is a negative 5. Negative 9 plus a positive 4 is a negative 5. So I have a negative 5x. Okay? So after you combine like terms, guys, this is what you should have. This is what you should have. Now, ladies and gentlemen, we're going to go to step 2. And step 2 is we're going to label each value and we're going to label each side. Now, whenever you see me put a heart, guys, that is the coefficient in operation with the variable. That's the coefficient times the variable, which is a relationship because those are two values that are in operation with one another, okay? And then whenever you see the S, that means the single numbers, which are just numbers, right? So that pound sign represents numbers. The heart represents the coefficient times the variables, okay? So negative 7x, I'm gonna put a heart underneath because negative 7 is a coefficient and x is a variable, okay? And they're in an operation with one another or a relationship, okay? 4 is just a number, so I'm gonna put S for single. 14 is just a number, I meant 14. So I'm gonna put X for single. And then negative 5x is in a relationship because negative 5 is a coefficient and X is a variable. So I'm gonna put a heart, okay? Now, it doesn't matter what side, guys, that you label as the relationship side and the single sides. You can label this side as the relationship side or the side where all the coefficients and variables go. And then the right side is where the single numbers go, or vice versa, right? But I always go with the higher coefficient that X is in operation with. Negative 5 is higher than or greater than negative 7. So I'm gonna go ahead and label this side as the relationship side. It doesn't matter, but that's just my technique, so I won't have to deal with negative numbers, okay? And then this side will be the opposite, which is the single numbers, right? So all I'm doing, guys, or all I teach my kids is just to match the symbols. If the symbols match, the value stays on that particular side. If the symbol does not match, the value needs to move. So right here, guys, the symbol does not match. So in order for us to move negative 7x to its appropriate side, I have to do the inverse of negative 7x, which is positive 7x or plus 7x, okay? So negative 7x and a positive 7x cancels out, and I'm gonna add 7x to negative 5x. Okay? So let's go ahead and continue on. So this 14 still stays. This 14 still stays. And negative 5x plus 7x is a positive 2x. Is a positive 2x. Now, the last thing that I need to do, guys, and that was actually step 3, guys, of me moving the values where they go. That's actually step 3 where I match the symbols. And then step 4, guys, I'm breaking up the coefficient from x, or x away from the coefficient, which is 2 and x, right? And to break up the coefficient in x, I need to divide the coefficient away, okay? So I'm gonna divide both sides by 2 in order for x to be by itself. So 2x divided by 2 is just x. And then 14 divided by 2 is 7. Okay? Okay, so 7 is less than x, or I'd rather for you to write it like this: x is greater than 7. Okay? That means x is greater than 7, right? So that means, guys, in order to make this whole equation true, x has to be any value, or it can be any value that's greater than 7. If it's a value that's less than 7, then this whole inequality would not be true, okay? So in order for all of this to be true, guys, x has to be a value that's greater than 7, okay? X has to be a value that's greater than 7. So, and also, guys, let me just go ahead and do it. I got time. So let's just pick a value that's greater than 7. So that means that x could possibly be 8, 9, 10, 11, 12, or any value that's greater than 7. That's what x could be. So let's just try out 8, guys. Let's just try out 8 just to see if 8 is going to make sure that the inequality is true, okay? All right, so what I'm going to do is I'm just going to plug in 8 as x. So I'm just going to write wherever I see an x, I'm going to put an 8. So I have negative 2 times parentheses x, which is 8. So I have 8 minus 12 All right, 8 minus 12. Okay, minus 5 times parentheses 8 plus 2. Okay, 8 plus 2. Has to be less than the other side, or the opposite side, which is negative 9 times 8, because x is 8, plus 4 times 8. Okay, so once again, guys, if me plugging in the value of 8 as x will make this whole inequality true, then that lets me know that the answer that I have is true, or that proves that the answer that I have is true, okay? And once again, I can do the same thing with all these other values, okay? So let's go ahead and try it out, guys. So remember, order of operations, we gotta solve what's in the parentheses first. So I have 8 minus 12, which is negative 4. And I have 8 plus 2, which is 10. Okay, so now I have negative 2 times negative 4, which is a positive 8, right? And then now I have a negative 5 times 10, which is a negative 50. So that's going to be 8 minus 50. Okay, on that side, 8 minus 50 is less than, let me do the opposite side, okay? We got to multiply first before we add, so I have negative 9 times 8, which is a negative 72, plus 4 times 8, which is 32, okay? So 8 minus 50 equals a negative 42, and it should be less than the opposite side, which, let's do that. Negative 72 plus 32 is a negative 40. Is a negative 40. So yes, guys, this is true because negative 42 is less than negative 40, right? So this proves that our inequality, our answer, is true, right? X has to be greater than any number that's greater than 7. Or it has to be greater than 7. Any number that's greater than 7, X could be. So X could be 8, it could be 9, it could be 10, it could be 100, it could be 2,000. Whatever number that's greater than 7, that's what X has to be in order to make this true, okay? So thank y'all so much, guys, for tuning in. I will come out with a couple more examples going over the same concept. Thank you for tuning in. Have a great weekend.